Hey, this is Mrs. Radigan with a lesson on geometric series. So we learned before that a series is the sum of the terms. If it's a geometric, it's of the geometric sequence. If the sequence in series is finite, it has a given number of terms, 1 through n. And the formula to find the sum is equal to the first term times 1 minus the common ratio raised to the number of terms over 1 minus the common ratio. If you have an infinite sequence or series, that means it continues without any ending term. So you can find the sum when the series converges. That only happens if the ratio is less than 1, something like a half or negative 1/4. If the series diverges, the ratio is greater than 1, you cannot find the sum. So a ratio like -5 or 4 or 3.5 would have no sum. So this is an illustration of why you can find the sum of an infinite series as long as the ratio is less than 1. So you can see here, if you multiply by a half each time, you are getting to the next term. So we can find the sum of that by taking the first term and dividing by 1 minus the ratio. So this one says to evaluate the finite series, which means to find the sum, and this is the sum formula. We are given that A1 is 5. So here's our A1. We can see from this that R is equal to 3. And the thing we don't know is what is our N value. We don't know how many terms we have, but we know the last term and the first term. So we can set up an equation. 5 times 3 raised to the n minus 1 is going to get us to 1215. So we just need to solve this equation. So we would divide by 5, and we would get 3 to the n minus 1 equals 243. Now we're going to use our skills from the log and exponent unit that we did, and we're going to make these into the same base. So 3 to the n minus 1 has to be equal to 3 to the 5th. So we make n minus 1 equal to 5, so that means n equals 6. So now we know our A1, our n, and our r, so we're just going to plug it into our formula over here. So our sum of our 6 terms is the first term times 1 minus r, which is 3. Now we know n is 6 over 1 minus 3. So our sum of our 6 terms is 5 times 1 minus 3 to the 6 is negative 728. We divide that by negative 2, and we get a sum of 1820. Okay, a similar problem. We have 7, negative 35, and 175. So our A1 is 7. Our ratio we can see is multiplying by a negative 5. And again, we need to know the number of terms. So we're going to type in or make an equation. 7 times our ratio to the n minus 1 is equal to negative 546,875. So we're going to divide both sides by 7, and we're going to get negative 78,125. And we're going to have to put these both in the same base. So negative 5 to the n minus 1, negative 78,125 is negative 5 to the 7th. So we're going to take those exponents, n minus 1, and set them equal. And then we get n equals 8. So there are 8 terms in this series. The formula says take the first term, multiply it by 1 minus the ratio, which is negative 5, raise that to the number of terms, and divide by 1 minus -5. The tricky part right here is that you have to do this first before you subtract it from 1. You cannot make these two both positive because you're taking this number and raising it to a power. This actually becomes a positive number, so it's 1 minus that big positive number. So if we look at that on the calculator, we would take 1 and subtract, in parentheses, -5 raised to the 8th, and that gives us -390,624. So if we write that, we have 7 times that -390,624 divided by this. We can both make a positive because there's no other operation there, so we just have 1 plus 5, and so we get the sum of the 8 terms to be -455,728. So in this problem, we are trying to find the sum of infinite geometric series. That formula is right here, and we can only find that sum if it converges, meaning that its ratio is, absolute value of its ratio is less than 1. So let's take a look at A. We can see here that the multiplier is equal to 1/2. We know the 16 is our A1, so this is a converging sum. And so we can go ahead and find the sum by taking that first term and dividing it by 1 minus 1/2. So that sum is going to be equal to 16 divided by 1/2, which is equal to 32. If we look at the next one over here, we see that we have a multiplier of 3. That is greater than 0. So if it's infinite, we have no sum. Okay, part C, we're going from 1.1 to -0.11 to positive 0.011. So we're going to find that ratio by taking -0.11 and dividing it by 1.1. And that's actually going to give us a ratio of -0.1, or -1/10. So this one is less than 0, or less than 1, so it converges. And to find that sum, we're going to use A1, which is 1.1, divide it by 1 minus a -0.1. So that's essentially 1.1 divided by 1.1. So our sum is 1. If we go over here to letter D, we can see that we don't have the sequence of numbers, but we're given a formula, and in summation notation, we know this means infinite. So that means we're finding an infinite sum. As long as the R value, this is our R value, is less than 1, then we can find the sum. So the thing we first need to know is what is A1. So we're going to plug 1 in for n there. So 2/3 to the first is 2/3. So our A1 is 2/3, and so is our R. So when we find the sum there, we're going to take A1, which is 2/3, and divide it by 1 minus 2/3. So that's essentially going to be 2/3 divided by 1/3. And that is going to give us a sum of 2. If we were to look at letter E, this one has an R value of 2, so this one diverges and we have no sum. This one is a working backwards problem. So we are given the sum, we are given the first term, and it tells us to find R. And we know it's infinite, so that means we're using the formula S equals A1 over 1 minus R. So we're going to plug the 100 in for the sum, and we're going to plug the 20 in for A1. So we get 100 is the sum equals 20, which is the A1 divided by 1 minus R. If we want to solve that, we can go ahead and multiply both sides by 1 minus R. And that gives us 1 minus R times 100 equals 20. So then we divide both sides by 100. And we get 1 minus R is equal to 0.2. And we just solve for R. So we get negative R equals negative 0.8. So R is equal to 0.8. Okay, so we're going on vacation. Yay, it's almost summer break. And we are going to find the sum of money that we'll have if we start with 125 and we save 8% more each month than we did the last month. And we want to know how much we'll have after that 12 months or that year. So the 125, that's our A1. If we save 8% more than we did last month, then our multiplier is actually going to be 1.08, like we did in the previous unit. So 1 plus 0.08. So R is 1.08. And then we have everything we need because our N right here is 12 months. So we're just going to plug that into the formula. So the sum for the 12 months is going to be our A1, which is 125, times 1 minus our 1.08, which is R raised to the 12th, divided by 1 minus 1.08. And we just go ahead and calculate that. So we're going to go ahead and type in that 1 minus 1.08 raised to the 12th there and hit enter so we know what our number is that we need in parentheses, negative 1.51817. We could actually just go ahead and do this on the calculator here. So we could multiply that value by our 125. And then we could divide that. Make sure you put that in parentheses, 1 minus 1.08, or you can just do it in your head and take it divided by negative 0.08, and you get a sum of $2,372 approximately and 14 cents. So they will be saving $2,300 and about $72 here for their vacation. So when does a geometric series have a sum? So this is the finite, and this is always has a sum as long as we know the number of terms. This one is infinite, and it's only if the absolute value of R is less than or equal to, well, not equal to, just less than 1. And that's it.